Welcome to Chapter 8 of Gen Chem. In this chapter we will be working on types of reactions, looking at trying to classify different types of reactions, balancing them, and then writing out the chemical reactions, and eventually we'll learn how to predict products, which tends to be a little tricky at first, but you'll get good at it eventually. Now let's start with a little bit of review. I'm going to give you some tips and tricks here to kind of shorten some past things you've learned and simplify them. That'll make your life a lot easier this chapter. So how can you tell if a compound is ionic or covalent? If you remember from chapter 7, on types of bonds, you find the difference in electronegativity, but you don't really need to go through all that work. When you're looking at a compound, if you look at the formula or the name, if it's made of a metal and a polyatomic ion, it is going to be, that will be an ionic compound. So put a little I there in your notes. A metal plus polyatomic ion is an ionic compound. So you don't have to go through, look up electronegativity difference. You just look, oh yep, there's a polyatomic ion, it's ionic. If you got a metal and a nonmetal, that is also ionic. And then the last case is if you have two nonmetals, then you know that your compound is covalent. So you should be able to look at compounds and pretty quickly decide if they're ionic or covalent. And that'll come in handy this chapter. Now when you look at the name, if there is a prefix in the name, that means it is covalent. If you see di, tri, tetra, penta, it's covalent. If you don't see Roman numerals in the name, if you don't see prefixes in the name, or if you see Roman numerals in the name, it's ionic. If you see a Roman numeral, automatically ionic. Otherwise, what you're looking for is if it has prefixes, covalent. If it doesn't have prefixes, ionic. So let's do a little bit of practice here. Decide if it's ionic or covalent, then name them accordingly. I'll do the first one right away here. If I look at this is sodium, which is a metal. This is acetate, which is a polyatomic ion. That means that this is ionic. And then to name it, sodium acetate. And then don't forget, I got to double check, does sodium have more than one oxidation state? The answer is no, so I don't need Roman numerals. But if it did, I better put Roman numerals. I only put Roman numerals if it's ionic and if there's more than one oxidation state for the metal. So you got to meet both those criteria. In this case, the sodium only is ever a +1, so no Roman numerals needed. I want you to give this one a shot. Okay, hopefully you got it done in your back. I see phosphorus and oxygen, they're both non-metals. So this is a covalent compound. To name it, phosphorus, and then oxygen turns to oxide. And then I got to put my prefixes in. Let's see here. 4 is tetra. I'm going to drop the A, so it's just tetroxide. And then 2 stands for di, so I'm going to go diphosphorus tetroxide. If you put tetraoxide and didn't drop the A, that's not the biggest deal. I'm not going to be too concerned about that. Again, give this one a shot. Okay, I'm back here. We've got nitrogen, hydrogen, both non-metals, so this is covalent. And then we'd say nitrogen. And then the hydrogen turns to hydride. Oh, I'm struggling to spell here. Hydride. There we go. Got it. Now, the first element, there's only one of them. So you don't put mono ever for the first element. You drop the prefix if there's only one of them. But for the second one, the 3 is tri, so it should be nitrogen trihydride. It's covalent, so it needs prefixes. No Roman numerals necessary. We're good. The common name for this, though, is ammonia. No one would actually call this nitrogen trihydride. Give this one a shot. Okay, here's what I do for this one. I've got a metal and a polyatomic, so that means it is clearly ionic. The Fe is iron. The PO4 is phosphate. No prefixes because it's ionic. This is where it gets a little tricky for students, is they forget, okay, do I put prefixes, no prefixes, Roman numerals, no Roman numerals, because now we're just blending two chapters together. So make sure you take the time to study ionic, no prefixes, covalent prefixes. And because iron does have multiple oxidation states, it can be +2 or +3, I need to figure out what it is. In this case, I've got phosphate, which is a -3. 2 -3s adds up to a -6. That means this side must be a +6 to balance. There's 3 irons, so 6 divided by 3 is +2. So in this case, it's iron 2 phosphate. And I went fast through that. If you need to go back into chapter 7, first part of chapter 7 shows you how to do Roman numerals and oxidation numbers. Okay, now given the name, is it ionic and covalent? Then write the formula. In this case, we've got iron 3 chlorate. If I see Roman numerals, automatically I'm thinking ionic. There's not much question there. Now the iron is Fe. The chlorate, if I look up on my yellow sheet, is ClO3. Because it's ionic, I've got to do some charge balancing here. So I go back, chlorate is a -1. This iron can be +2 or +3 on my yellow sheet, but this tells me that it is +3. No need to actually look it up. That means I need 3 of these. So I'm going to multiply this by 3 to balance out this +3. So if I need 3 chlorates, I better put this in parentheses and put a 3 there. Dihydrogen dioxide. Now I see a prefix in front of each word, so that tells me it's covalent. Hydrogen is H. Oxide is oxygen. Di stands for 2, so I better put a 2 after each of these. H2O2, which is also hydrogen peroxide as its more common name. Lithium bromide. Okay, this one isn't super obvious because there's no Roman numeral, but if I look, there's no prefix here, but that's a possibility even if it's covalent for the first element not to have a prefix. But no matter what, if it's covalent, there's always a prefix on the second element or the second name. In this case, there is no prefix, so that means that it is not covalent. It's ionic. If this were a covalent compound, there'd have to be some sort of prefix here. The fact that there isn't tells me that this is not covalent. So now I go LiBr, and I check lithium on my yellow sheet. It's a +1 charge. Bromine is a -1 charge. This balances, so LiBr is my final answer. Sulfur dioxide. And again, I hope you're pausing the videos before I do them so that you give them a shot on your own. So sulfur dioxide, I see a prefix here. Just what I was kind of ranting about up here. There's a prefix now, so that means it's covalent. Sulfur dioxide. So sulfur, oxygen, di means there's 2 of them. That is where we are going to end this video. I'll try to keep the review separate from the rest of Chapter 8. So if you didn't quite understand this, I would recommend going back, and there are videos in Chapter 7 and 6 that go over how to balance ionic compounds better, how to balance their formulas. If you didn't get it from the last chapter, this chapter is going to be a struggle because it's going to be expected that you know how to do some of this stuff. Talk to me, go back, watch that if you need to. But the only option that I would say is you should not do is just pretend like it's okay that you don't know this. So if you are finding that you're struggling, make sure you get help or do something to fix your dilemma here. But always reach out to me if you need help.